Our next speaker, Chris Biscardi, is an independent educator and engineer who has been working on the web for over a decade. And we will be hearing about websites, web apps, and WebAssembly. Come on up, Chris.
Hello. Testing. Hello. Cool. Hey. Thank you for coming to see the talk after lunch, after second break. Hope everybody can get their coffee in and whatnot. We're going to talk about websites, web apps, and WebAssembly. WWW, which is, I still laugh about that I put that on the front slide. We're going to talk about Rust and a little bit of JavaScript. We do have to level set, so we will be talking a little bit about web history and stuff like that. But the takeaway that I want to bring to everybody today is that we kind of have this opportunity where Rust can run anywhere JavaScript can. I'm not, telling you to write Rust only. I'm not, telling you to write JavaScript only. They work well together in all sorts of spectrums. So the takeaway from this should be Rust and JavaScript work really well together. If you're a JavaScript first place, you can integrate Rust. If you're a Rust first place, maybe less JavaScript, but Important to note also that we are talking about wasm, but we're not talking about server-side wasm containers, that kind of stuff. No WASI in the talk today. Also no NAPI. Native extensions for Node and stuff like that. We're going to be talking about Rust and JavaScript WASM in the browser. And since we're talking about web technologies, you're not going to get away from using these two. You're going to have to use HTML, you're going to have to use CSS, kind of the bedrock of the web these days. Well, forever. Why did I say these days? So we need to level set a little bit, right? One of the things that came up when I broached this topic with people is that we kind of don't necessarily have a large community understanding about what it means to develop for the web these days. There's been a lot of developments over the last 10, 15, 20 years. So we're going to talk a little bit about the developments that have happened there and where that puts us today. So a brief and scattered, cherry-picked, if you will, evolution of web development. We're going to start briefly in 2006 with jQuery. We're going to hit Node and NPM and then maybe make it a little bit closer to Rust. So back in mid to late 2000s, we're working with very split front-end, back-end technologies, right? If you're on the back end, you're using one language. If you're on the front end, hopefully you get the opportunity to use jQuery, because if not, good luck. But this approach still works today. But the needs and complexities of modern web development have evolved as users have had more experience with the web and come to demand, more interactive, more engaging experiences. So from there, we hit about, 2010-ish, and single-page applications all over the place, right? This is Backbone, this is Angular, this is Knockout.js, if any of you remember any of that. We didn't already have the APIs to make this really a great experience. You might remember a bunch of, hashtags in the URLs because we didn't really have URL support. And this is all very client-side stuff, like no page refresh. Great experiences for things that are highly interactive and client-side, but you lose the server, you lose some browser APIs along with that. So early 2010s, we get Node.js. And Node.js is I guess the cornerstone of what evolved into modern web development, because it's hard to imagine where we would be today without it. So this allows us to put JavaScript on the server, which is really important because that means that we no longer have to have this two-language gap, which means that you don't need to duplicate, say, your Vue logic in two different places. There's fewer opportunities for bugs in the future because you only need to write it once and run it in both places. On top of that, there's this real huge influx of tooling, right? Node.js allows you to actually write tools in JavaScript and distribute them to other people who can run them outside of the browser, which is a huge thing at this point, right? So we get this absolutely massive influx of tooling. JavaScript gets a package manager. Interesting to note the development of like Rust is happening like just after this time, kind of like 1.0 in Rust happens just after this. So what we have from Cargo today is influenced by NPM and Bundler and what came up in sort of this time period. But NPM gives us a registry, so now you get to actually be able to ship packages and the ability to run them as well. This introduces things like build scripts, dependency graphs, eventually MPX, which is also a very, very cool tool. And then we get into the kind of like second half of this timeline. We've got, bundlers and then React. Whenever I say React in this talk, by the way, I don't mean like React specifically. I mean like React and Vue and Solid and Svelte, and it's a long list, Then there's this like 10-year gap where we kind of hit the baseline and then develop that baseline for a long time. And that gives us a number of different technologies, which leads us to kind of like where we are today. So let's talk a little bit about bundlers. Require.js, Browserify lead into Webpack here, introduces dependency graphs, multi-asset management. And you can compile and run in, now the browser and the server. So Webpack, extremely pluggable, develops this ecosystem of tooling. Again, we talked about multi-asset management and the dependency graph. This is CSS pre-processing. And it's important to note that this is like very featureful. Like the stuff that we were doing by hand manually in the jQuery days, where it's like write a script, write another script, copy one into the other, save a new file, ship that. That's all automatic now, right? And it's important to note also that like JavaScript isn't really, we'll say, progressing at that time. So people are like very hungry for the next ECMAScript release, which leads to a lot of tooling, a lot of transpilation, compilation, whatever you want to call it these days. Source maps, minification, CSS processing, chunking of JavaScript bundles, all sorts of things like that all happen around this time. And then we get to like the Reacts and the Vues, right? And the major thing that I want to point out here is that we end up with this sort of path from Node enables us to run JavaScript on the server in the browser, but we don't really take that much advantage of it until frameworks enable this like API called render to string is roughly what I'm going to call it for the purposes of this talk. And that's basically like take your React components, take your whatever, render it to a string, send it to the browser, rehydrate in the client. Now you actually have a thing where you can like, write some components, use them in both places, not have to duplicate the logic in both places. And this leads to something that I roughly call like a UI service, which is like, if you think of UI before all of this, you think of like the browser as the client, right? If you think more in a microservice architecture like mentality, you can think of the client and the server as being a UI service, and then the APIs that we used to build with that backend technology can move over to a different microservice, but this other set of stuff is still all consuming those APIs, right? So we end up with this like UI service, so to speak. And that gives us this single language stack. Only really relevant in the context of talking about like before we had to split it and now we don't have to split it. It doesn't actually have to be a single language. So that happens over the next 10 years. We get a whole bunch of sophisticated rendering technologies, a whole bunch of sophisticated like data fetching technologies. For example, if you were going to render to string, you have to fetch everything, then render, just like templates, then send it. We don't have to do that anymore. And then we wrap around all the way almost to jQuery, right? So we get this like very automated, tooling-rich ability to basically ship islands of interactivity, which if you think about the way that we were doing jQuery and attaches to different DOM nodes on the page, we basically just automated that, wrapped it up in a bunch of tooling, and now we don't have to do any of that manually, which is really great. So that's our history lesson. What is modern web development then with all of that in mind? It's this UI service. It's this idea of we have these frameworks where turning on and off different very complicated pieces of technology that empower different approaches, whether it's a static site, a server side, client side, islands, different kinds of data fetching, async, sync, in order, out of order streaming, all of these things, they're all kind of becoming like checkboxes in this UI service. So it's an important distinction between like before, if you wanted to change the way that you were shipping things, you had to change the architecture of how you built it, right? And now you kind of don't, right? It's kind of just like, okay, I want to, you know, like render ahead of time, so I have a static site. Or I want to render at runtime and I have, you know, a server, etc. It's also important to note, or interesting to note, that Rust and JavaScript, like we said, work very well together. And it's already powering like the next generation of JavaScript tooling, right? So we talked a little bit about Webpack, and at this point, the world hasn't quite moved beyond Webpack yet, right? It's been around for 10 years, people are still using it, it's still fine. But the next generation of tooling, like RSPack, that sort of progresses that lineage, is built in Rust, and so is roll down, which is, you know, continuing roll up. And then I've included parcel here for kind of all of the other things that don't really continue that lineage specifically. But there's a lot of them these days, and they're all kind of using Rust at this point, which is really cool. So we're going to take a look at what it means to do like modern web development, and we're going to take a look through the perspective of Leptos. Now, Leptos is kind of an incidental decision here. It could be, you know, any other kind of framework, but you're a Rust crowd, so we're going to talk about Leptos. This includes things like data, suspense, signals, etc. Leptos supports all of the data fetching strategies that modern frameworks support, and all of the rendering strategies that modern frameworks support. So we talked a little bit about components earlier. If we're talking about what modern web development is today, it's kind of very component based, right? You need to have, or you don't need to have, but you have a component which can be as small as a button, maybe a button with a click handler, some styles attached to it, and you use that all over your site, right? It can be as big as your entire application, but the same way a unit of compilation in Rust is a crate, the unit that people think about in, you know, the web is kind of a component these days. And in Leptos, you can see this is like an attribute macro on the top. We've got regular functions, some traits. If you know Rust, this doesn't look all that unfamiliar to you. Maybe the JSX HTML looking stuff, but. And then you have to decide like, okay, when and how are you going to fetch your data, right? Like we talked about earlier with render to string, you kind of had one choice. You had to get all of your data, you had to pass it into that function call, and then you had to render all the HTML out. But now, with things like suspense, which is kind of like a feature name that is across all of these frameworks, and other things, you get to decide when that happens, right? So with suspense, you can say, hey, I have open graph meta tags that have to block, right? I need that Google SEO bot to actually get my meta tags every time. It always has to go down. So block before, and then send the HTML down when that's ready. But maybe we have, you know, some data that's behind a client login or whatever. In the same server pipeline, we can say, block for this, wait for this either now in the same pipe that we're sending down, or wait for this later, fetch it back on the client, etc. And this supports, you know, async await these days. I'm showcasing some Leptos 0.7 APIs, which is almost released in this example. And then we've got server functions. Server functions are really interesting. Server functions are really interesting because when you first look at them, you go, wow, that looks like a security vulnerability waiting to happen. It turns out they're not. This is just some syntactic sugar on the client over, you know, HTTP request as usual. And on the server, if you have a server function, it just calls the function, right? So there is no like special sauce going on here. There's no like taking your database access and like shoving it down to the client in some way. This is just syntactic sugar that is well typed, that can operate either from a client call, which makes HTTP request, or on the server, which is just a function call. And, you know, like Leptos, for example, you can have middleware, you can have a bunch of configuration, wherever this ends up being an API URL, right? Server functions also very interesting in terms of thinking about forms, right? Forms are huge on the web. You need forms. I can't think of a single application off the top of my head that doesn't use some kind of a form, right? I guess if you're just displaying a document, but you know, the original use case, right? So action forms, you can take one of those server functions that you just created, turn it into an action, pass it into this form, and then we kind of scrape back some of those drawbacks that we saw with single page applications earlier, because this form will work whether there's wasm or JavaScript or not, which I feel is pretty important. And I'm really excited to see this in modern frameworks these days. We're kind of clawing back those things that we used to miss, the things that were very obvious, like, hey, that doesn't work. It really should, because it works by default. And now we have those again. And then we get to talk about rendering. And rendering and data fetching end up getting very complicated very quickly. Static site generation, server-side rendering, client-side generation. The core point here that I want to make is that they're all the same process. If we mental model as that rendered to string, even though the models are more complicated, the mental model can still be kept there. Then you get to decide when your data fetching happens. You can call render to string whenever you want, before, when we're actually running the server, or on the client, and all of them kind of work, right? This allows you to kind of like checkbox between sync and async data fetching. In and out of order streaming become kind of like a little checkbox, right? And what are checkboxes in Rust? Enums, more or less. So these are all possible, right? And if we start talking about rendering modes, this is the kind of thing that I'm talking about, right? SSR equals some enum variant. This doesn't look that different than the way that you would write it if you were going to write it and not deal with this at all, which is kind of the point that I want to make, right? The history of modern web development leads up to this point at which we start creating these larger meta frameworks. And these larger meta frameworks really give us the capabilities to build one application and configure it the way that we need to actually ship our applications. And this is not restricted to just JavaScript meta frameworks anymore. And that brings us to islands. Islands are super interesting because it basically, like in my mind, full circles us all the way back to jQuery, but takes out all the bits that were like annoying and manual and like things that humans shouldn't have to do, like concatenating two scripts together. Islands are basically, like I said, the same thing as components, especially in Leptos, where all you have to do is change the top attribute macro. I don't know if any of you recognize this code from an earlier slide, but it is the same code that I showed when I showed you what a component was. It is just now an island, which means that now only this code gets sent to the client instead of our entire application, which might be very, very static and, wasteful. So in a sea of static content, islands. But there are also downsides, right? Like downsides of anything, trade-offs on anything. In this case, there are a lot of things that we do today in JavaScript land that don't necessarily translate very well at the moment. We're going to talk a little bit about code splitting and a little bit about ecosystem sizes. Code splitting is not a thing that you are going to be able to do in wasm unless you want to put the effort in to be the person who made it work for everybody. If that's you, you're wonderful. If that's not you, you're going to have to wait a little bit. This technically works, but it's only available in previews, right? Like only available in demos, only available, like technically we can get this to work, but you're not going to be able to download it Leptos today, install it, and just get code split bundles. And if you're not familiar with code splitting, usually what it means is that like per route, you might have a big chunk of code, right? Like maybe you have your home page, and then you have like the page that has the Netflix watch screen, Maybe you don't want to ship the Netflix watch screen on the home page, even though like it doesn't exist on both pages anyway. Code splitting is kind of like the solution to that problem, more or less. And then obviously ecosystems, right? If you're going to do front end today, if you're going to pick a JavaScript meta framework, you're going to end up with, one of these choices at some point on the table. And to say that React is dominating this space is kind of an understatement. So there's React at the top here. There's Vue below that at like 5 million. And then you get into like niche JavaScript meta frameworks. And calling them niche is a little bit of an overstatement, right? People choose these for production every day. They choose them and they go with them and it works for them. So if you're comfortable choosing what I would say a niche JavaScript meta framework, then you could also be comfortable choosing Leptos today. And what about integration, right? There was a talk earlier, Ben, one of the maintainers of Leptos, did a little community talk, and people were like, what about integration? How do we work with the rest of the ecosystems? Because like, there's a lot of code over on NPM, like a lot of it. And rewriting all of that code is sometimes just not tenable, right? So, framework-specific code, if you have something that is like, oh, I don't know, like Framer Motion, which is like just React, it's like a React library, right? Then, just like anything else, you're not going to take a React library and use it in Vue. You're not going to take a React library and use it in Leptos. JavaScript libraries that want to own the DOM, things like rich text editors, you're going to have to take a little bit of special care for. It's not that they can't work. It's just that you need to care about them a little bit more. They're not just like drop in and everything magically works. And then obviously any JavaScript libraries and SDKs from third-party companies, maybe you're using like, I don't know, Mixpanel or something, or you're doing analytics or something that somebody told you to do. You might have to build that yourself or bind it yourself, depending on what your solution is. So that's basically the entire talk. I just want to make sure that we have a shared understanding here about WebAssembly. It feels a little bit like a magic box, right? And I just want to talk a little bit about how easy it actually is to build WASM with Rust. You don't need any of this like higher level meta framework tooling. You're probably going to want it if you build a production application, but you don't need it, strictly speaking, right? So here's a Rust lib.rs, right? It's not that different from a lib.rs that you would normally write. It's an add function, takes two use sizes, returns a use size, right? The important parts here are no mangle, because we want to be able to call add from JavaScript. So like if we mangle it, we're never going to find it. And then we have to define the external interface, right? And this is like very low level. This is very, very, very like not what you would write if you were writing a Leptos site, but it is enough to get a wasm out the other end. So cargo build, target wasm32 unknown unknown. You get a wasm file. You fetch that wasm file. You instantiate streaming with the browser APIs that are just supposed to work. And then you can just call the function. That's how easy wasm is with Rust, right? So there's something really strong to be said here about that. You probably do want better tools, and we have them, right? Wasm bindgen, wasm opt, Leptos, etc. But it is actually this easy to get some wasm binary, send it to the browser, and actually use it. So for me, personally, when I choose to do a new site, the first thing I consider is, Leptos or Rust and wasm based approaches. You get all the benefits of running a Rust server, right? Memory usage, performance, et cetera, et cetera. And you can also just ship stuff to the client, like we talked about earlier. So you get this like single stack effect that we were talking about. You get this UI service. And it's comparable, which is about the best thing that I could say because there's so many options to choose from, right? Should you do this is a much different question. Maybe, maybe not. I'm not really here to tell you to go rewrite everything in Rust, just like I'm not here to tell you to rewrite everything in Vue or Solid or React or whatever, right? But I'm here to tell you that this is a very real possibility. There are people doing this in production today, and you would not be, the first unique building my own framework person to be doing this at this point. You would still be on the earlier side of the adoption curve, but you're not the person building the framework, right? So there's a couple things that I talked about in this talk. This site, This Week in Bevy, is a site that I run that is Rust and wasm. If you want to try to go load it on the conference Wi-Fi right now, you're free to do so. That is a site that is Rust, wasm, Leptos, ships islands. It's great. I tried it on the Wi-Fi earlier. And then there's Leptos links here, more links in the Discord for the conference. And thank you.